Alright, so hello, our project is the solar tracking cell with a humidity-dependent wiper. Um, as you can see right here, the purpose of our project was to create a solar tracking cell that was really efficient, more efficient than a standard solar cell that doesn't move. Um, Something unique about our project is that not only does it like track the sun, but it also wipes the sensor, so it would wipe any dirt or fluid or moisture that accumulates on the surface of the solar cell. And this is really important because it helps increase the efficiency of the solar panel, which in turn generates more power, which in turn creates better solar cells. And a big bonus about this is that it's completely automatic. There's no human interaction required, and yeah, that's a general introduction to our project.
So for our project, we have two light sensors. We have a servo motor. We have a stepper motor that is underneath this base here. And we also have a humidity sensor. And so the general way this works is these two light sensors will compare like their values, and then whichever side has a brighter light source, the stepper motor here will rotate in that general direction until these light sensors have an equal value. And then for our humidity sensor, once it reaches a certain humidity level, then this servo motor here will activate and it'll wipe the solar panel by moving 90 degrees back and forth 4 times. And the purpose of this is that whenever you're placing this solar panel somewhere, let's say in like a certain environment, once it reaches a certain dew point, you can calculate that like relative humidity, and then you'll know that there's going to be condensation on the solar panel, and that's when you want to wipe the humidity off as well as wipe off any dirt, because whenever you're wiping wet dirt, it's going to be more effective than just wiping off dry dirt.
For mechanical design, we opted to stick to 3D printing due to its benefits and quick prototyping. All of our mechanical components were printed using a resin printer. The base at the bottom contained a cutout for the stepper motor. A stand was designed to fit snugly over the motor shaft and go over the base. We designed a system of dovetail slider keys and keyways for the top portion so that we could attach the stand, panel plate, and photoresistor and servo mount attachments all together. This helped us reduce the size of the prints when prototyping, since all the parts are broken into pieces instead of just being one massive part. As the name suggests, the panel plate holds the solar panel, the photoresistor attachment holds the photoresistor, and the servo mount holds the servo, which has a wiper mounted to it.
So this is how our code works. We would first off by importing these libraries in order to use those electrical components that we bought, and we would assign them to certain GPIO pins on the Pi Pico board. As shown here, these are for the light sensors. This is for the stepper motor. We created a step sequence for the motor, so this would be one direction and this would be the opposite direction. We set our servo motor, set an angle, and then define these functions for this motor, stepper motor to run. And this is our main loop. We start off by having these two readings from these light sensor, and we would find their difference. We also find the humidity and temperature readings from the sensor, and then we start off by printing off the sensor reading and their difference. And we print the temperature and humidity, and then if the humidity is above 55 and the motor hasn't triggered yet, then it would sweep to 90 degrees and back to 0 4 times. And then if the humidity is under 55, then the motor wouldn't move. And for the light sensor, if the difference is above or equal to 100, it would print out that the motor is spinning, and then it would print out the updated values for the readings from both sensors and their difference, and spin the motor using step motor once. Then once the absolute difference is less than 100, then it would print out difference met and stop the motor by braking. And then if we start the code and the absolute difference is already less than 100, then nothing will happen and it'll print out no motor movement needed. And then if the difference is less than negative 100, then it would spin in the reverse direction using step motor once reverse, also printing the updated values. And then once again, as it's spinning and the difference is less than 100, then it would break the code and the difference would be met. So right now I'm going to start the code. As you can see, since the difference is less than 100, it's going to print out no motor movement needed. So now I'm going to shine a flashlight onto one side to show that it moves. I'm gonna point it. So these are the two light sensors above right here, hid by this blue part. This might be hard to see. I'm going to point it on this side. I point it, it starts rotating clockwise, and you can see that it's printing the updated values until the values are equal. It stops. I'm going to try on the other side. It's going to keep spinning, giving the updated values. Stop right here. Now the difference has been met since it's facing the bright spot, and the difference is less than 100, so we'll stop right there. Now for humidity sensor, the only way we could do it is by breathing onto our humidity sensor. That can be seen right here. So once the humidity sensor is above 55%, then it would the wiper turbo motor, so wipe back and forth. Demonstrate that, and it will show you the updated values of the humidity sensor as shown up below under the sensor value readings. Wipe. And that is how our code works.